Hello everyone, this is Samin Paudel and I'm doing lab 2 of IOLab, like installing IOLab application. Okay, I have already opened IOLab software and we can see our IOLab activities in this folder over here. So this in the lesson list we have lab 2, we have 10 lab based on real-time physics, and these labs were like these were developed and written in Portland State University, okay, for the IOLab design. And okay, let's start as we are doing lab 2. Here we can see which is titled as Introduction to Motion. Okay, so you may go ahead and write your member name, your group member's name, your name. For us, we are doing it individually, so let's just write your name only. Okay, last time I did lab 1 thoroughly, giving the key concepts, but this time I'll be giving the key and the concepts and the steps to do the lab. Okay, not in detail. Okay, so let's start. As you can see, the dongle is not paired, yeah, and the device itself is not paired. So for that, let me show you the video again. Okay, this is what it is dongle, reminding you. Okay, you have to put it in the USB port of the computer. Okay, if you have Mac, you might not have the port to like port to connect it. Okay, in that case you have to get some device that will allow you to connect the dongle to the Mac. Okay, if you can see the dongle is paired now, let us power on our IOLab device, and you can see the remote one will be paired with some configuration. Okay, this way just connect, and now you can see it's already paired. Okay, okay, starting in this first slide, there is nothing. You just have to write your name, and you'll just it is giving what we'll be doing today. Okay, you will analyze position, time, velocity, position, time graph, velocity, time graph. Okay, basically the introduction to motion. Okay, let's save and go next. Okay. Okay, let's start with the investigation one, in which we will be saying position versus the time graphs for the different kind of motion. These are the things that we'll need. Okay, and you may read through these. Okay, so save and go next. Okay, so again, let's stop again, reminding you guys again. I have already talked about the positive axis here, y-axis here. So you may see in this one, in here, the positive y-axis is towards the single wheel. Yeah, if you see from double wheel towards the single wheel, as I have already mentioned, double wheel towards the single wheel will be the positive y-axis. Like here, you might in your device you might see it in opposite direction. Okay, let me see. In your device it is in opposite direction. Okay, but actually the lab is written in such a way that it has to be in towards the single wheel. Okay, if you see in the opposite side, it's in the single wheel or where the eye bolt is. Okay, so okay, we'll start by placing the wheels, the IOLab with the wheels down in the stable top. Yeah, smooth surface. They want us to move in positive y direction in the right. So we'll just keep it like this way. Okay, positive y direction is towards this side, towards single wheel. You can see the bolt here. Okay, now they want us to move it, hit the record bottom and move the IOLab with slow and steady. Okay, well that, let me show you with the figure and the graph itself. Okay, now if I hit the record button, okay, and then I can move it slow and steady with the same speed. Okay, you can move it like this with the same speed. Okay, you don't need to stop it. It will just collect data for 5 seconds. Okay, and then if you are not satisfied with this one, you may again do it. Like you can just do add run. Okay, let's do that. Let's start from the beginning. Okay, positive y-axis is towards this side, reminding you again. Okay, positive y-axis is from double wheel towards the single wheel. I have placed it like that. Okay, If you put it here, that's also fine. You can do it like this way, but it says right, just not to create confusion, I placed in that way. Okay, so from double wheel towards the single wheel. Okay, and then like if you are not satisfied with the first one, you may add run. Okay, and then you can record again, you see, so that the previous one will be there. Okay, you can record again, move slow and steady. Okay, with the same speed, with the constant. If it is constant, it has to be kind of linear. Yeah. Okay, actually, so I slowed it down at the end, so that's why it is kind of graph like this. Okay, I can do the third one again. Okay, so let's add run. You can start right far. I'm sitting right here. I'll record and then I'll move slow and steady. Okay. Okay, so it has just stopped there. And when you are satisfied, you may remove the one that you are not, like you can see, you can use. So let's keep the third one. You can keep like as you want. Okay. And I hope you know this is the workplace where we started to move, and this is straight line. This is the motion when I moved my IOLab slow and steady. Okay. Then you may go and save and go next. Okay. It will take us to the next slide. The graph will be saved there, stored there. Okay. It will not be gone. Okay. In this one, they want us to repeat the steps to the graph, faster motion to the right. Be sure to collect the data for the entire 5 seconds. Yeah. Now we'll be moving it fast, like we are moving slow. Then now we'll be moving it fast. So yes, let's do it again. So you may start from that same position again. Okay. And then we'll start record run. Okay. And then we can record. Then this time we'll be moving fast so that everybody will constant the same speed. Okay. Okay. I ran out of room, but that's fine. So they want us to do it for all 5 seconds. If that makes sure you know your region of interest. Okay, this is where I stopped. So that's already stopped. So this is our region of interest. Okay, let me do it again. So add run. If you have like longer space, you might collect the data for whole 5 seconds. Okay, but you don't need to stop, as it will stop after 5 seconds. Okay, so you can record it again. Now move it fast this time. Okay, I moved it fast. Okay, I think you can. So you may keep any of those. Okay, as per your interest. Okay, so let's keep the last one and remove. So don't remove the one that you got from the while running slow and steady. Okay, it has to be there, it should not be removed. So that was, make sure you know, that was the first one. So this is the last one. Let's remove the second one. Okay, so comparing this. Okay, so our data, like we may compare up to this time only, because at this time the IOLab was stopped there. This is the time IOLab was moving fast but with steady speed. This is the time where the IOLab was moving slow but with steady speed. Okay, so you may describe the difference what you have seen. Okay, so in this one and write in your own words. Okay. Okay, after you describe in your own notes in slide 4 what you see, and then click save and go next, it will take you to this slide. Okay, and in this one they are asking you to move, this time they are asking you to move your IOLab towards the left. Okay, now we will change the direction and see what happens. Okay, let me make it a little bit small, or I can just put it here. Yeah, that will be more helpful. Okay, so they want us to move to the left and see the difference what's happening. Okay, actually you can do it by yourself, but make sure do not remove the previous run so that you can compare. Okay, so this time they want us to start from left. Yeah. Okay, so we are okay. Be careful. So it has to be in the same positive y-axis has to point in the same direction it was pointing, but this time we'll be moving towards left. Okay, if we were here, so we'll just start to move from left from there. Okay, but now since we do not have room there, we'll start from this side. Okay, but make sure positive y-axis is pointing to the same direction that you did in the previous one. Okay, so that pointing positive y-axis is towards that direction, towards the single. Okay, towards the eyeball. Now we'll be moving towards the left. Okay, it's in opposite direction to positive y-axis. So they want us to use slow motion to the left. Yeah, now you will record. Okay, and think now we'll move slowly to the left. Okay, so make sure you analyze. You can collect the data for inter 5 second, analyze the data when you are moving, just when the IOLab was in motion, slow and steady. Okay, So you may repeat the process again and make record of the previous graphs. Okay, you should not remove this. These were for the positive ones, so you should not remove. You do not remove these ones. You may remove. You may collect again if you do not get the satisfactory graph, or you miss, like sometimes you stopped in the middle, something happens. So you may add run record again and remove the one that you don't need. Okay, okay, then you may click save and go next again. Okay, now let's see what they have told here. They might have said to do it fast now. Okay, so repeat the steps, faster motion to the left here. So then you can start from the same position here. Positive y-axis is towards the single wheel, so positive y-axis is this side. Okay, this, if I start here, positive y-axis is this side. If we want to, if we move right, that would be positive y-axis. Going left would be negative y-axis. Yeah, now they want us to do the same thing, but in like move to left with faster speed. Yeah, like fast speed, but the speed has to be steady. Okay, let's do the thing again. Let's record it. Okay, now they want us to do it some fast motion. Okay, but with the steady speed. Okay, if I'm not satisfied, I will start again. Or if, okay, let me add the next one. Okay, but you have to keep the record of which one is which. Okay, let's add run. Let's record. Now move with the fast speed. Okay. Okay. Now, okay, so be careful. First runway from the previous one, which we had did. Okay, now we may remove the one that we are not like satisfied with. Okay. Okay, and then now you have the graphs, okay, to analyze. So make sure you describe in your own words, and then you may click on save and go next. Okay, you may repeat it a couple of times, and just you may add on if you are not satisfied, and remove the one that you don't need. But make sure you do not remove the one that you need from the previous slides. You will need those. Okay, so do not remove those. Okay. Okay, after you explain in your own notes in slide 6, and then click save and go next. Okay, reminding you, please do not forget to click save and go next before going to the next slide. Okay, like do the things what you have to do in the slide. For write the answers, write the description, record your graphs, whatever is asked in the slide, then only click save and go next. Okay, and then as based on the concept of real-time physics, they will predict. We'll make a prediction first. Yeah, we'll do the experiment, and then we'll analyze. That's the technique of the real-time physics. So that's what it has been asked in slide 7. So you may go ahead and make your prediction. Okay, you may go ahead and make your prediction and click save. Make a prediction, click save and go next. Okay. Okay, now after you have made prediction in slide 7 and clicked on save and go next, okay, then they want you to do the experiment. After you make the prediction, you do the experiment and see what the result is. Okay, they have asked us here to move the IOLab from at the origin slow and steadily toward the right, means positive y-axis direction for 5 seconds, then stop for 5 seconds, and then move it back to the origin twice as fast. So then we have to move back. They want us to, for each instance, collect for 5 seconds. Okay, so if you have is okay, if you happen to have, let me share the picture with you. Okay, and then that way we can. Okay, you might not be able to move for entire 5 seconds in every step. Okay, so but make sure the nature of the graph, like if you compare the nature of the graph in the prediction. Okay, you may wish to do 3 seconds to the right moving slowly, 3 seconds stopping, and 3 seconds moving back with the faster than the twice faster than the one you had in the beginning while moving to the right. Okay, so okay, let's try to do the experiment. If we are able, we'll do until the 5 seconds. But if you happen to have this board, like not of, we should have longer board. Okay, so let's see. Maybe we can try. Okay, then we can record. Okay, they want us to move towards positive y-axis in a slow and steady way for 5 seconds. Yeah, and then stop for 5 seconds, and then go back fast in twice speed for 5 seconds. Okay, I think the graph, nature of the graph is not that. Okay, so let's do it again. Okay, so if we if we are not satisfied with the result, you may compare with this one also, but Let's do it again so that we'll have a clear picture. So we'll start from here, but we have to make sure we return back to the same point. Okay, return, like we will consider this point as the origin. You may start from here also, but we'll have lower space to move here. So let's start from here, considering this as the origin. This is positive y-axis towards positive y-axis. Yeah, from double wheel toward the single wheel. I voltage here. We can know from that as well. Okay, and then let's add run. Let's record. Okay, let us move it slowly for 5 seconds. Okay, slowly, slow and steady for 5 seconds until some position. Then I'll start for 5 seconds. Okay, and then I'll go back in the fast, but for 5 seconds, I think I moved a little more. You see, I go into the negative side, so we have to be careful. Let's start from here and do the third run. Okay, so you may do your own run as much as possible. Okay, so we'll consider like we'll consider from 2 to 6 to 7 seconds as slow speed. Okay, let's do like that, and then 6 to 11 around as, and then after that we'll stop. Okay, let me like that. Okay, I run. We cannot, like, we may start from exactly here, but usually it will not be possible for students. Okay, so it's record and just keep on moving is not a prompt thing that we can do. Okay, so let's add run. Let's record. Okay, now you want to move slow and steady. Okay, steady until some time. Then we'll stop. Okay, I started to, so I'll move around 10. Okay, then go back fast. Okay, let's do. Okay, so we are satisfied with the third run. Let's remove this one. Okay, that was the first one. That was the second one. Okay, so you may go and compare with the prediction. Like in your prediction graphs, that might start just exactly at 0 second. Okay, so make sure you compare the nature. Okay, so you started at 2, we consider around 5 seconds with the slow and speedy, and then we stopped, like we stated for race. Then we move back to the left to the origin with twice as fast as the origin, and then okay. And okay, you may go ahead and describe your prediction, your result, what's the difference. Okay, and then click on save and go next after you write your description here. Okay. Okay, now reaching up to slide 9, you may have already known which side you have to move to create positive slope, which side you have to move to create negative slope, how fast you have to move to create what kind of slope. Okay, like if you move slowly, the slope will be lower. If you move fast, the slope would be higher. Okay, so those things you might have already known. If you stop, the position is going to be still. Okay, so based on that, okay, you have to make this motion, this kind of motion, okay, by moving the IOLab. So try to do it. Okay, you can, I'll just give it a single try. So you have to give it a try, move it, and so describe how you move to create that graph. Okay, you may go ahead. I just saw it. I might not get an exact one, but this is, I'll just show it for once. Okay, so you can go ahead. Okay, so let me start from here, since I already know they are moving in positive slope. Yeah, so this is positive slope, so right, moving towards positive y direction would be the one will be required. So let's start recording. Okay, then we'll see here. Okay, I think they move at 6 seconds, so they're moving quite fast. Okay, then they stop again. I have run out of the room, so, and then okay, so you need a longer board to do that. Okay, it seems that, so I have a trick, but I'll apply the trick, but for you, you may use in the longer one. Okay, let me add run. Okay, let me start from here. Okay, so actually I think you can do it. You will need a longer board. Okay, so you can use a longer table, and then you can continue from that. Okay, so I'll just use the trick, which is not advisable. Okay, you may have a longer. Okay, so let's start. Get started, and then okay, now where it is. Okay, when it comes here, I'll just do it like that. While stopping, I'll just use the trick. I'll just move it back, but it's not recommendable. Okay, then you can. Oh, that's not good. So let me do the last one again, last try. Okay, add run. I'll start from here. You may remove it if you don't like. Okay, I'll keep the first one since it was quite. Okay, so record it. Okay, In the beginning it is not moving, so I'll just keep it like that way, and then when it comes that 6 seconds it moves with the abrupt thing, yeah, and then it stops. Okay, I made a mistake again. Let's go back, and then it will move like this and then stop again. Okay, so you may do your own one way. So you have to make the graph that was initially there. Okay, so you have to make that one and describe how you moved your device to create the graph. Okay, whether you moved slowly, you moved towards right, whether you moved towards left. Okay, or how did you move? Did you move with this steady speed? Did you move fast? Then you come. Okay, let me remove and say okay. So describe what did you do? Did you stop? Where did you stop here? You what, like, were you moving right or left? Were you stopping? Were you moving right or left? Were you moving right or left? Were you moving faster here than compared to this one, slower here compared to this one? Try to describe, try to replicate the graph and describe in notes here, and click save and go next. Okay. And for now. Okay, in slide 9.1, I was able to like get close up enough up to this one. You may not get close enough up to this, but okay, try to do it and explain how did you move to get this graph. Okay, whether you move to a right, whether you moved fast, whether you moved to a left, whether you stopped, when you stopped, what time. Okay, maybe you can mention the times or times also, at up to from this time to this time I did this, from this time to this time I did this kind of thing. Okay, describe in your own words, then click save and go next. Okay, and then okay, so this is a prediction time again. Okay, okay, just no, this is, you have to make a motion like to graph like this. Okay, so try to match the position graph like this in here, and describe how you made the graph again. So same like this. Okay. So you can try to make a curved graph. So you can see whether the slope is positive or negative. If the slope is increasing, like how can you make like this? Okay, and then describe how did you move to right. Okay, so let me give it a try. So I can see the slope is positive and the slope is increasing. Okay, so let's see. In that case, so you can record it. Okay, so let's see slowly. Okay, so this is not exactly, but kind of. Okay, let me record the new one I run. Okay, and then I can record again. So let's see how close I'll get. Okay, so you can try as long as you like. Okay. Okay, and the next thing, okay, so you might out of room, yeah, as you do not have like a longer board or something. If you have longer board, that's fine, but if you run out of room, it's not that you have to get the whole graph. Yeah, whole graph is not of interest. If you see here, okay, so what you can do, as we have already used the tool, so you may zoom it. Okay, so just the one you need it. So if we see here, this is kind of this here, then okay, actually let's remove the first one or second one, anyone would be okay. I think it doesn't make that difference. So if I see here, okay, you can just select the one up to your interest. Okay, because okay, so kind of that's one. Okay, so try to replicate the graph and describe how did you get the graph. That should be good to go. Okay, in slide 11 also you can try like to replicate the graph. Okay, the difference is you can see that had higher slope in the slide 10, it had higher slope at the end, but it had higher slope in the beginning, but now, and it is the slope is decreasing, but the slope is always positive. You may see that. Okay, so you can move very fast in the beginning and then slow it down, like move with higher speed in this one, then slow it down. Okay, so try to replicate the graph again and describe you how you move to get the graph in your own notes. Okay, whether this direction is positive or negative. So if you see here, it's already like we have a positive slope, so we have to move towards the right. Yeah, so you have to change the speed while moving. Okay, so try to do the right in notes that make replicate the graph here as much as possible. Okay, and then you can move from there. Okay, in this one, same thing. You are asked to replicate the motion. Okay, so you can see the difference. We are moving with positive slope previously. Now we are moving with negative slope. So you have to move in negative y direction, varying the speed. The higher slope means higher speed, yeah, lower slope means lower speed. So it had lower slope in the beginning, but and the slope is increasing continuously as time increases. So try to replicate the graph and write in your own notes. Okay. So what is the general difference between motion that results in a straight line position and the curved one? So let me give you a hint here. Like in the straight line, it was always a constant slope, but in this one, the slope is constantly changing. For instance, if you see there is a kind of slope here, yeah, there is a different slope, and the slope is different here. So you may describe in notes, try to replicate the graph. Okay. Describe how you moved it actually to get the graph. Okay, up to slide 12, we are looking in investigation one. We are looking, we are analyzing how position time graph changes. Yeah, with different kinds of motion in different direction. If you move to positive y-axis, right hand from the right from the origin, what is the kind of slope when you move it with steady speed? So what happens if we move slowly? What happens if we move fast? What happens if we move towards left? What happens if we move towards right? You have to know those things from investigation too. Okay. Now we are trying to see how velocity time graph changes with the most during the motion. Okay. So when moving right, left, and then we'll see. Okay. You can maybe click save and go next. Okay, now you'll record velocity insert the graph axis. I think we'll be doing the same thing. Now we'll be seeing velocity versus the time instead of position. That was position versus the time. Now we'll be saying velocity versus the time. Okay. Okay, as in the position versus time graph, we have to move slow and steady for this starting. Okay, slow and steadily towards the positive y direction. Again, positive y direction is from double wheel towards the single wheel. Okay, towards the eyeball. If you start, you may start from this position also, but the positive y-axis you have to be moving towards the positive y-axis. Yeah, generally we are trying to make right as the positive y-axis, but it is not compulsory. Okay, so positive, make sure you move toward the positive y-axis where you are keeping it. So this is positive y-axis is from double wheel towards the single wheel. The eyeball is here. You keep it here. Okay, now they want, like, we will be doing the similar experiment actually like we did for the position versus time, but the result will make analysis based on velocity. Okay, you may go ahead to click record. Okay, and then you may click move with slow and steady speed. Yeah, they want to make steady speed. Okay, if you are satisfied, that's fine. If you are not satisfied, you may add on. Okay, and then you may start again. Okay, we can record it. Okay, and then move with slow and steady speed, slow and steady speed, slow and steady speed, slow. Okay, you may keep on moving until you get the what's that called, satisfied result. Okay, so I think both of them looks okay for me. Okay, so let me say one thing. In theory, like while seeing the actual graphs, okay, you may see a straight line from the beginning or those kind of things. Okay, but that is not necessary. So for here, actually, our region of interest will be where we were moving our lab slow and steadily. Okay, so right now, so for this case, my interest would be from here to here. Yeah, I was moving my IOLab slow and steadily up to this point. This is the start when it was 0 in the race, and then I just gave abrupt speed. So you may neglect this one while doing the analysis. Okay, slow and steady starts from here, and then this was I'm kind of slowing down. So you may take the reason from here to, like, from here to here only by doing the analysis part. Okay, so that was slow and steady. Okay, moving on to the next one. Okay, making velocity graphs. I think now you have to do the same, do it in medium fast speed. Okay, and then write in your own needs, and then click and move and go next. Okay, so let me try it. Okay, I can try it. So I'll start from here. Okay, so then we can, so makes you know which one is for the slow and steady. Okay, so you can it says medium fast and steady. Yeah, so you can click on record. Then I can okay, then okay, let me click on record. It is good to start from the same. Oh, sorry, that was not good. Okay, so let me start again. I run record. Okay, it's good to start from same. I'm moving medium fast. Okay, so I ran out of space again. That what I said previously will come into play. So let me remove the second one. So what I said previously is like, based on reason of our interest, I was moving with medium and what's it called, medium fast and steadily in this region only. Okay, so you may analyze, compare these two. I moved, that was slow, that was medium fast, and this is the only reason that why I was moving medium fast and slowly. Okay, so we will not get a perfect line that we see in theory. Okay, So you can ignore this one. You may do the analysis from here to this part only. Okay, so describe in your own words what you see, what is the difference and those things, and you may save and go next. Okay, I'm just writing something else. So just to make your save and go next. Okay, you may describe in your own words, so it's not going there. Okay, so slowly now they want to do it in the left as we did it for the position and what's the time. Okay, now you will start from this side, like not like you may start from any side. So but we are saying left and right, that's why we consider this as origin. Okay, positive y-axis is our right, that's our left. So if we start from here, they want us to do here. You may start from here and move to the left. Okay, make sure your positive y-axis is moving like is in that side. Double wheel towards the single wheel is positive y-axis. You may point that way. Don't follow the positive y-axis in your device. Positive y-axis is like if you positive y, you may, if you have it from double wheel to single wheel, the positive y-axis in your device, you may follow it. Okay, but usually what so far with what I have seen, the positive y-axis has been drawn is from single wheel towards the double wheel in the device, but that is not the way the lab has been written. It has been written in a way that positive y-axis is from double wheel towards the single wheel. Okay, so you may do the run from towards the left now. Okay, so you may start from here and move towards the left. Okay, and then see what will be the results. So you have to move from single wheel towards the double wheel to get to as if it is moving like left to the origin. Okay, so you may start from this side, positive y-axis is this side. Now you have to move slow and steady to get the left. You may go ahead and do it. Okay, left, and see the difference what happens. Okay, I don't know if I want to show you, but okay, I'll just pause it and let's see what happens. Okay, let me do the one quickly while moving towards the left. Okay, slow and steady speed. You may start to record, and then we'll move the IOLab slow and steady. Okay, slow and steady, slow and steady, slow and steady. Steady means same steady. If you are not satisfied, you may do the run again. So you can add run. Okay, record it and do slow and steady. Okay, the speed my vary. It's up to you. Okay, and then okay, let me remove. So make sure which one is which. Okay, so this is the one I want to remove. Okay, it's kind of weird, but slow and steady. Okay, so this you can analyze it from here to where the speed is kind of steady, constant, slow and steady. Okay, and you can save and go next. Now they want you to do medium fast. Let me just quickly so towards the left. So positive axis is pointing towards. I will moving towards the left. So and fast. Okay, so okay, doing that one, and then I will move fast but steadily. Yeah. Oh, I stopped again, so I'm not satisfied. I can add the run. So record it. Okay, and then I'll move. I have to move with the same speed. Okay, that's the main concept. Okay, I can okay, if I'm not satisfied at that time also, I can just move at the same time also. Okay, you may record it, and then okay, I think I'll be quite satisfied. It's okay. So you may try to get it like move it steadily. Okay. Okay, so let me give it an extra. Oh, I didn't record. So you may record it. Okay, and then let's move with the same speed. I think that was okay. So if I remove this one, so you have to know at which time you are moving medium fast and steadily. Okay, so that time will be, it's like some I have seen students analyzing the whole thing, so that's not the important thing. So important thing is at what part of the lab you are doing the motion that is asked in, like asked you to done. Okay, in the slide, like you are asked to move slow and steady, you are asked to move medium fast and steady, yeah, towards the right, move slow and steady towards the left, medium fast. So this will be the only part that we need for medium fast, like that was where I was moving medium fast and steadily towards the left. This is okay. So describe in your own words and you may move forward. Okay, so now, yeah, time to make prediction. Go ahead, make prediction based on what you have only while moving left. You now you have, you know how what happens, what kind of position and velocity graph will get while moving to the left, while moving to the right, while moving fast. Okay, you may go ahead and move to the prediction. Okay, then based on like whatever you have predicted in slide 18, now we'll do that in slide 19 and see as the concept of real-time physics. Yeah, so they want you to move to the right, slow and steadily for 4 seconds, hold the IOLab still for 4 seconds, and move to the left steadily about twice as fast before 2 seconds. Okay, keep the plus y direction of the other to the right as before. So plus y, keeping plus y to the right. Okay, so in this lab, I think it's throughout the lab, I think it's good to keep positive y axis towards the right. Okay, from the origin, like you can, if you consider this as a reference, keep the y axis, like keep the positive y axis towards the right. That will be good. Take that as a positive y direction throughout the lab. That will make things uniform. Okay, so let's see. So positive y axis is towards right, from double wheel towards the single wheel. This is our right direction. Okay, let's start from here, so that okay, the origin kind of thing. Okay, and then you may go record. Okay, you may start move for 4 seconds, slow and steady. Okay, slow and steady. Okay, 2 to 6 is fine. Then I stop, yeah, for 4 seconds, and then I move back. Okay, I didn't do it for longer time. Okay, I can do that again. Add run. Okay, okay, and then you may remove it right now also if you are not interested. Okay, then go ahead, record. We start so slow and steady, slow and steady, slow and steady. So I'll start until 5. I will stop. Okay, and for 4 seconds I stopped, and then I move 5 with medium speed. Okay, actually it didn't happen for 2 seconds, but okay, so you may see what might have happened. Okay, let me do the last one, and then you can try on your own. Okay, until you get the ready. So slow, you have to record it. Okay, then I move slow and steady for how much seconds? Something like 4 to 5 seconds. Okay, then I stop it or something like that, and then I move with the medium fast speed. Okay, like that one. Okay, so as I say, so slow and steady, medium fast. So you can make the difference, see the prediction. If it is, I think they want 7. Go next. Okay, it is kind of like representing the velocity in terms of vector, yeah, like in terms of arrow and the direction, left arrow, right arrow. Okay, okay, if any vector has longer length means higher magnitude, shorter length means lower magnitude. For now, I think we will be pointing toward the right, we will take it as positive, pointing toward the left, we will take it as negative. Okay, so based on that, you will have to make the analysis. Okay, so which velocity vector above best represents the following motion described. So as I've already said, so you read this thing and make your decision. Okay, so moving slowly towards the right means right. I said if moving right is positive, arrow facing positive, left arrow facing negative, left is arrow facing negative. Okay, if it has longer magnitude means, okay, so if we have longer magnitude arrow, shorter magnitude arrow. Okay, shorter magnitude arrow means if it is for velocity, it means it will have lower velocity. Higher magnitude arrow means it will have higher value of the velocity. Okay, for instance, if you see here these two, if you compare these two, considering this as velocity vector, this is also for the velocity vector. Okay, both are pointing towards right, so they both are positive. Okay, and this means this has lower magnitude of the velocity, and this has higher magnitude of the velocity. Okay, if you compare these two, okay, if you see they both are moving, they both have equal magnitude. Yeah, actually they both have equal magnitude, but the direction is different. So this is moving towards the right, moving towards the left. If we say this as slow, this as fast, this is moving fast right, moving fast left. Okay, so length determines the magnitude of the velocity. Like right now it's a vector quantity is velocity we are seeing. Yeah, and arrow defines the direction. So based on that, make your, so just like answer these questions and you may move to the next slide. Okay, and reminding one thing, if there is no magnitude of the vector, then it will be represented as a dot. Okay, so there, if it is not, like if there is no moment, there is no velocity, so if we want to represent is as an arrow, so we cannot do that. Yeah, so since it doesn't have any magnitude, if it is standing, like if it is stopping, it doesn't have any value, so no length of the vector, just a dot would be okay. Okay, friend, the next slide, in slide 21, so you can go ahead and just try to replicate this graph. Yeah, so if you see whether you is not moving, so you can just stay there, then this velocity is positive. I hope you already know whether you have to move left or right. Okay, positive means right, obviously. Then based on that, try to like and see the length of time you have to do that also. Okay, and the velocity is steady. In this case, they are not changing. Okay, so if it doesn't, so you can add on record and do the thing. Okay, okay, this is just prediction. Okay, so you might not do describe. Okay, so in prediction you might go ahead and predict it. Okay, but do not click save and go next until you write those things. Okay, it might be difficult to write, so do the prediction. Okay, then you, so I think they want you to do that now, so do this. So try to make this graph while moving, whether you have to move right or left. Okay, just to give you a hint. So this is not moving, nothing. Yeah, zero vector. So this is moving steadily, so it's positive. Is it moving left or right? Just move right towards the positive direction. Yeah, and then same thing. So and see the span of time also. Okay, and describe how you move here. Do not click save and go next until you feel this one. Okay, just for this one, this is just a hint. So that this concept for the lab, so I'm just doing that one. Does the velocity graph tell you the motion of the IOLab started, where the origin is? Can we to tell about the position? So do we need can you see if the where did the IOLab start from the velocity time graph? Since it doesn't define the position, I don't think so. So big, you may go ahead and analyze those things. Okay. In the previous slides, okay, this slides make sure you do the like recording and match. I think you have to do it in this one. Yeah, this is the place. Click record and begin graphing. So you can do it in this one. You might not need to do add run. I think I did it here, but you know, this is just prediction. You can go ahead predict how you might get these motions. In this one, you have to do the record thing and do get this one, moving your IOLab device right or left whenever necessary, stopping. Okay, whenever necessary. This one just analyze same thing, just more analysis about the position time graph. Now they are trying to rate position and velocity. Now you may go save and click next. Okay, I don't think this will be necessary. I don't know why I was just playing. Predicting velocity graphs from position graph. So saying your position graph, you should be able to predict the velocity graph. Okay, so okay, I think position graph is given, and based on that you have to predict the velocity graph. Okay, so how will the velocity graph look like? So tell you again, rate of change of position is velocity. Okay, so that might be a hint for you. So make your prediction. Okay, this is a slope kind of thing. Okay, make a prediction, and then you may click and save and go next. For now, this is not the answer. Okay, I'm just making I'll just do the random thing and then I will move ahead. This is not a right prediction. Remind you, not a right prediction. I'm just clicking haphazardly. It might be, I don't know. Okay, I have not seen it. Okay, now they want to do it actually. So while doing, we already did the position and time graph. Yeah, okay, we already did position and time graph. We already did velocity and time graph. So to create this position, what will you do? You see, there's a kind of constant thing. Yeah, so moving. So how did you move? How did you get this one? You may go back and see it. So this is kind of linear thing, or whether you move slow, fast, you can do this one. Okay, and match this one and see how will the velocity look like, and you can explain based on that. Okay, I might give it a try if you want, but okay, let me give it do this. Okay, so I'd say, okay, just this one. Okay, let me show you the video also. So I can see this is positive slope. Yeah, so that means I have to move towards positive direction. So let me see, double wheel towards the single wheel, towards the right positive y-axis. Okay, and then there's no change in position, so that's not moving. Yeah, that's a constant kind of thing. So we might not start right away from zero. It has right away from zero. Okay, I might be moving or somewhere around one because I have to record and move myself. Okay, that will happen to you also. So let's see. Okay, and then I'll move with some speed for some time, and then I stop. Yeah. So you may do your analysis. It's already stopped. If you are not satisfied, you can do it again. You can start from here. Okay, okay, 0 to 4 seconds. So let's do for around 4 seconds at least. Okay, you can add on. I can record it. Okay, I was slow and steady. Okay, and then I wanted to stop. Okay, that's okay. You can remember the first one. So I don't know. I tried to match. So based on that, you can see. Okay, how would the position graph to be different if you move the IOLab faster and slower. So do they want you to do it? Okay, this is just predicting. So what happens if you move faster? You have to write those answers. Okay, did the velocity time agree with your prediction? How did, while doing it, did they agree? Okay, so how would the velocity graph be different if you move the IOLab faster, slower? Okay, so what will be the same if you move faster, slow? Okay, I didn't know that, but try to make the prediction. You may do the experiment also. Predicting position graphs from velocity. Now looking at the velocity graphs, it is just opposite. Yeah, you have to predict the position. So after doing all of this, you might have already known. Okay, so this is what there is, velocity is 0. So what will be the position? So it's not moving, it's constant. Yeah, 0. So nothing. So there is positive slope. You see, the velocity is constant, means there will be positive slope in the motion of positive y-axis. Okay, so you best, sorry, if you have a constant positive velocity, means there you need a positive slope in position time graph. Negative slope, sorry, negative constant velocity, negative slope in position time graph. So based on that, you can see whether, based on that, you can predict your position. Okay, so just, it's just a random thing. I'm not doing it. I'm just making a random guess. I click B also. Okay, so you make sure you see the velocity graph. Based on that analysis, what you have done before up to this point, go ahead and this one. Okay, predicting position. So you may do the graph. Okay, and see which one you may be right. You may, so this is not moving. Yeah, we already did that. So we have, from our previous thing, we may say this is constant, moving steadily toward right. Yeah, then moving still toward left, and then constant. Okay, you may go ahead and do it. Okay, let me just give it a try. I'll just give it a try. Okay, it might not be wrong, but you have to make this graph. Make sure you can do it. You can do it by yourself. Okay, so it was stopping, then it was moving for, oh, I did the right thing, but okay, I'll do continue with this one. Okay, and kind of that one. Okay, I did not move for exact time of second, that is indicated also. Okay, so kind of, oh, but it, oh sorry, I think I did a mistake. I stopped here. Yeah, but there is no stopping, it's just abrupt. We have to do it abrupt. Okay, so let me start it again. Okay, and then I can edit. Okay, I don't need to add on, I can record it. Oh, yeah, I didn't click. Okay, let me record it. Okay, and then I can move slow and steady as indicated. Slow, I cannot stop, I just have to move back abruptly. Okay, I think I did it in the wrong way again, but that is how you can do it. You can give it your own try. Okay, so try to match this graph. Well, this graph has to be here. Okay, somewhere here, and you can, based on that, make your prediction. Again, predicting position graphs from velocity. So we have been doing that. How can you tell velocity? Okay, seeing the velocity graph, how can you predict the position? That's what they are saying. Okay, it's about knowing the relationship. Okay, how can you tell from a velocity time graph that the object's motion is steady? How can you tell from a velocity graph that the object's motion is steady, constant or not? So velocity graph, how can you tell from velocity graph that moving object has changed direction? So you can look at the sign. Yeah, it's positive, it's negative, whether it has changed direction or not. Okay, so go ahead and answer these questions. I have just done as a reference. Okay, so that's all done. So again, same process, you can save and go next. So if you want to save it, you have to go here. Okay, so we just use this lab too. You may edit your, you write your name. Okay, and then you can write your name and save. Then you can write your name, save it, click on this one. This will create a PDF file. Okay, export to PDF and save in your required location, and you can do this lab. Okay, so it was just giving the concept. Okay, so I was just giving a concept for this lab. I might not have written every answer, so be careful of that. So I was just trying to show how to do the lab only. It's not like the lab. Okay, yeah, and that is all. Thank you.